You want to make sure that instinctively that when you look at a graph, you of course want to recognize like if it's going to be a polynomial function or if it might be some other function like a rational function or whatever. We're going to get into graphs of lots of different sorts of functions in the future, but at least for right now, all 10 of the graphs that you're seeing here, they are all graphs of polynomial functions. So I'm not trying to trick you in that regard with this. Um, Later on we'll start to differentiate between different kinds of functions and start to recognize like okay, this would be a logarithmic function, etc. So given that all of these are graphs of polynomial functions, we're just asked one simple question at the top right there, that what is the degree of each polynomial function, right? So the degree is supposed to be the highest exponent of all the different terms in a polynomial, right? So that would mean, like, is it going to be degree 5, which means this is a graph of a quintic, right? Or maybe it's degree 2, so then be like a quadratic, like a parabola, right? So when you look at some of these graphs, like when you look at this one right here, you can tell because there's so many bumps in it that it's not going to be like a degree 0, 1, 2, 3, like that sort of thing. You at least for sure know that because the ends go in the same way, that it has to be an even degree, right? So it's got to be like, degree 2, 4, 6, 8, that sort of thing. But because this has 1, 2, 3 turning points at least, then the degree, right, always is going to be higher than the number of turning points because the most number of turning points that a polynomial function could have is exactly 1 less than the degree and then like even multiples from there. So it can't be a degree 2, right? Because if it was degree 2, it'd be like a parabola. And parabola, it's not a parabola, right, because it's got more bumps. So at least we know that this is going to be a degree 4 or higher. It's probably a degree 4, but it could, in theory, be degree 6 or 8 or 10 or 12. So basically, we at least know like the least degree of this right here. So like the least degree of this polynomial function is 4. So it's got to be a quartic function. Otherwise, maybe it's a 6th degree function or 8th degree or whatever it might be. Okay? And then when you look at like the second graph right here, you can see that the ends are going in opposite directions. So then it's got to be an odd degree function. And then you could tell that like it's not going to be degree 1 because it's got some bumps in it, right? So it's got 2 turning points exactly. So that means that the least degree would have to be at least 1 higher than 2 turning points, which would be 3. So yeah, then the least degree for this one would be 3. So it is a cubic function. Hypothetically, you could say like, well, maybe it's 5 or 7 or 9 or 11 or 13 or keep going to infinity, right? Like some odd number. But you can just kind of tell for that one, right? It's going to be a cubic function. Okay, so you kind of get the idea. I'll just kind of fill in the rest of the numbers. So like, feel free to like pause the video right now and just like try to figure out on your own right now before I give the answers what like the least degree would be for all the rest of these. But you can kind of basically tell at this point that this one right here, it's got 1, 2, 3, 4 bumps in it. It's going opposite directions, so this one's going to be 5 for least degree, this one's going to be 2. You know that one's going to be degree 0 because it's a constant function, right? The equation is y equals 5, so it is degree 0 for sure. Like, and you kind of tell like that one is degree 2 because it pretty much looks like a parabola, right? This one's least degree would be 6, this one would be 3, this one's got to be least degree 4. This one's kind of interesting because you can see there's like this little inflection point right there. When you get those little inflection points, like you can kind of like add 3 to the total. So like you already got a turning point there and a turning point there. This has got to be at least 3, but it's definitely not 3. So it's, well, I guess, so maybe like 5, right? It's got to be odd degrees because it's going different ways. So probably 5, maybe it's 7 or 9. Probably 5, yeah. And then the last one is going to be degree 1. Because it's a diagonal line, so it has to have like an m value in front of x plus b. Yeah, so you should at least be able to tell, right, from the graphs when you look at it based on like the curviness and that sort of stuff, like what sort of polynomial function are we working with here, right?